Hi, this is Larry. What I want to talk to you today is about Cardinal Sim. Cardinal Sim is a CPU simulator. It was developed by John Kress, a former information technology faculty member at Milwaukee Area Technical College. It basically allows students to see how a CPU works, play with it, and test operational codes. Basically, you want to understand how chip thinks. Actually, more importantly, how chip works. So let's take a look first here at the screen. What you're seeing on the major screen here is basically the elements of how this is all going to work, the simulator works. On the right here, it says memory display. Let's just assume this is memory, and this memory is going to be in RAM. And every memory location has an address, 00 here to 99. Okay, so you have 100 addresses or spaces to put instructions and data inside of it. Basically, everything that you store and run has to be stored into a memory address location. And those are instructions, and those is also just plain simple data. Okay, but everything has a memory address, and that's what this represents. On the left of it is going to be the control unit, and this whole big black area, you think about the CPU, and you have the control unit, you have an ALU. And if you notice inside of it, it has an instruction register, which is another internal memory location, and an accumulator, which is another internal memory location for the CPU. And then if you notice over here which says fetch, increment, interpret, and execute, those are the 4 different steps that all CPUs actually go through to complete your instructions and move on to the next instruction. All right? So remember this, is that basically how computers work, or CPUs work in this case, is that everything has to go from the control unit, or basically the CPU, over to memory, take something out of it as an instruction, and then fetch it, and then be able to increment the register, etc., and then process it with the ALU as required if necessary. Okay? But basically you're going back and forth between memory and the CPU to get things out of memory and put it into the CPU to be able to operate it. Understand too is that the CPU works in a very sequential basis. Okay, it works down and just straight through all the instructions it has next on it. So it's a very sequential process. And what you're going to see as we run through this, how to actually how the CPU works, you'll see it's very sequential. It's pretty easy. So we have a control unit in the ALU. The ALU over here does actually all the mathematical calculations. So this is the CPU. This is RAM. Down below here is the input queue. This would imagine that the buffer, basically another memory address area that you would have for input. Imagine that a person is putting in a keyboard, putting input in. And then over on the left of that is the output. This means this would appear on your screen, on a printed screen, or a printed page, or whatever you want. But this is the input. This then becomes the output. And what you're basically going to be doing with this is understanding that you can take, you have to use codes and instructions that will be located inside your RAM memory here. When they get put into the CPU, the control unit will know what instruction is and what it means. At some points it will take elements from the input queue and put them into memory somewhere over here. And then it will then process them as needed, if needed, to put it into the accumulator so that it can keep track of it, etc. So you're going to see how this all works and how the 4 different stages. And understand there are 4 different steps that a CPU has to go through to complete every instruction. The other part of this then too is on the bottom here is the control panel and how to actually run the Cardinal Sim simulator. Basically, the only time you can put anything into memory here, or input queues, any type of data, the instruction codes or input to run when you're preparing for this, is when it's halted, or it's halted, meaning that it's stopped. The whole CPU is stopped, the simulator is stopped. To start it, you will basically hit the start button down on the bottom here, and that start button will start, and it'll ask you for what instruction or what memory address you're going to pick from first. Okay? And so always start with 00 and start your coding always at 00, the 00 memory address. For the purposes of running this on a test basis, that's a lot easier. And when you say start, then you can either step through it. Bing, bing, bing means it'll step you through each step as it goes through it. You'll see it goes through fetch, increment, interpret, execute, fetch, increment. You'll see how this runs, step through it. Or if you just want to see how it runs all together at one time, just hit run. Now let's take a look at how this will all work in the operation codes that are necessary. The operating codes used for Cardinal Sim, if you want to think of the operating codes themselves, the operation code is actually what is the instruction set that the CPU knows how to use. You will be using, it's a 3-digit code. The first digit means it's the operation code itself, the instruction. And the second will mean the memory address where that instruction that's being used, the memory address that's being used. Okay? So at the bottom here is that you have the Cardinal Sim operation codes for this. There's only 10 of them. 0 means input, 1 means clear and add to the accumulator, 2 means add to it, 3 is test, assign, and jump, 4 is shift left and right, 5 is output, 6 is stored, 7 is subtracted, 8 is jump, 9 is halt or reset, basically at the end. If you want more detail, you can look on this page that has more detail. These links are put into the work in the classroom and in the instructions for the assignments. Okay? So basically you have a 3-digit code. It's going to be the first digit is going to be the operation code, and the second is going to be the memory address being used. So let's take a look at how this will run. So what you want to do is when you're test running this first is you're going to need to go in the memory and put into the memory display different commands, operation codes, and you're going to put in here. So let's start with the first one. What I want to do is solve for the problem x equals 13 plus 105. Very simply, x equals 13 plus 105. We're simply going to add just two numbers and display their output, the answer to it. And what you're going to see here is how many instructions there are and operations there are, and how much the CPU, how many steps it has to do to process through that. The first thing we're going to do is then put in the first instruction into the memory. And if you notice, I have it highlighted here, in the 000 memory address here, the first memory address, is that I have it highlighted, and you want to always make sure you highlight and put all 3 codes in there to make this run correctly. And the first one I'm going to put in is 010. Okay, and the next one I'm going to put in here is 011. Okay, what I'm doing is, you can figure this out, see how this runs. Okay, and the next one I'm going to put in is 110. Yes, I'm being very quiet here. I'm trying to just allow you to see what I'm doing here. I'm basically putting in these codes very easily. It's not that hard to put in here. Just make sure you have them in order. What I would recommend, there's a coding form that comes with the assignment to do this. It actually helps if you can put these codes in order and check them out before you start putting things in here. Understand is that what happens in a real life, you would write code in C#, and that C# code would then be compiled down into machine code that would work with these operating codes with addresses like this. Okay, and understand every operation, every instruction also has memory addresses included with it, just very similar to what you're seeing here. So understand there's a lot of processes going on. I'm trying to give you a show of how chip here works so you have a better understanding of how to program for chip. Because the basic things we're doing, you're going to be doing, you can do as Cardinal Sim are very basic and rudimentary, but also when you get into programming, if you have an understanding how this works with memory going from addresses to CPU back and forth, and it's all about the data and the instructions, you have a better understanding, you become a better programmer from that. So let me just check again: 10, 11, 110, 211, 620, 520, 999. And then I need for my input cue, so down here on the left, I'm going to put in two numbers that we're going to add. The first one is 13, and the second one is 105. Okay? All right. So what I'm going to do now is I'm going to start it, and then I'm going to step through it to show you how this works. Just very easily, just step through it real quickly for a couple of these things, and then I want you to watch this, and we're going to run through it again so that you can see how fast this runs. Ready? Let's go start. It says entering the starting address. Just say OK. If you notice it's highlight at the top, we're looking at the first memory location, and it says fetch. It's the first step it's going through. I'm going to go down to the bottom here where it says step, and I'm going to click on it and step my way through. So it's going to fetch, increment. If you notice, it's got the instruction register now has the same instruction operating code that's over in 00. Instruction pointer was going to 00. Okay, we're step. Interpret it means go to the next instruction, get that ready to go into memory, which is 011. And now we're going to execute, read memory, cue, and input into cell 10. So the next step, it will do that. Boom. And if you look down here in memory cell 13 now, it did put what was in input queue 13 over into the memory of display, the RAM over here, into 13. And now that was only one sequence. There was only one sequence just to do all that. It took 4 steps to execute that. Now what we're going to do is we're going to fetch, step. We're going to go in instruction register says go to instruction 01. So we're going to step through that, fetch it. And you notice instruction register is now upgraded. We're going to increment. We're going to interpret. So it says go to the next instruction pointer. What the CPU is always doing is getting ready always to do the next step. So it gets everything in memory, clears everything it needs to do, gets ready for the next step because it interprets it, okay, and then it executes it, okay. And basically what it is read input queue into memory cell 11. So what it's going to do is take what's in here and go to 11. So I click on this, watch this memory cell 11 over here, step, there you go. So it moved it over there, copy, like you want to think about it, but it put that value over there. So understand, RAM will contain instructions or it'll contain data, right? The memory, that's basically all this is all about, instructions and data, right? So what it's going to do now is we need to go through the next ones. I'm just going to step through the next one here. You go through down and does the next one. It's pointing at instruction 2, so we're going to fetch the memory location 2 here. So what is it going to do? It's going to step. It's going to increment. So it says the next step after this will be 3. It's going to interpret it. And it says it interprets it and says clear accumulator, which is down here on the bottom. Okay. And then it'll add it to into the contents of cell 10. So it's going to add into it whatever's in cell 10. So basically, because it said 110, it's going to take clear what's in here and take what's in cell 10, which is 13. So watch what happens in the accumulator. 13 appears in the accumulator. And then the next step will do what? It'll take what's from the next cells and add them in there. You'll watch what happens here. So when we get to 211, it says take what's in 11 and add it to here. Watch what happens. I'm just going to run through this real quickly and how this all works. So I'm going to hit run. Stepping through everything, boom, it's done already. But did you notice all how I clicked through, did everything else? At the end, we would have display output 118. And if you notice, memory address 118.20 up here has 118 in it. So what it had to do to accomplish this, it had to add this all, move this over here, then eventually move it over to here. So what you're going to have to do when you play with this is you're going to have to remember you have to do all these steps. How to move things in and out of memory, okay, and also in and out of the accumulator, and then display it output. Make sure you check the documents that are included with the assignment and also in Blackboard. Have fun and good coding.